Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, what do the physicists think of the robots? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the topic of robots for inspection and maintenance. This time of some of the most delicate and precise scientific equipment in the world. Before that, I'd like to remind you that you can send in your questions for my future guests, either by contacting us on social media, we're at Robot Talk Pod on all the socials, or you can submit questions via our website by going to robottalk.org. And don't forget to enter our competition for a chance to win your very own Robot Talk t-shirt. For more information about the competition and how to enter, check out robottalk.org. So, with all that said, it's time for me to introduce this week's guest. I recently had a great chat with Mario Di Castro from CERN, all about robotic inspection and maintenance in hazardous environments. Today I'm speaking to Mario Di Castro, who leads the Mechatronics, Robotics and Operation section at CERN. Hi Mario, welcome to the podcast.
Hello, thank you very much for this invitation. It's a pleasure to talk to you.
Likewise. So first of all, can you give us a little bit of an overview of some of the different robotic systems that you have in use at CERN?
So at CERN, mainly we use different robotic systems with the goal of doing remote maintenance.
Mm-hmm.
Our robotic pool ranges from ground robots, so ROVs, to snake robots, or hyper-redundant robots. We also have drones, and recently we also added a quadruped, a small dog that endorsed our remote maintenance capability, especially to reach a challenging environment.
Okay. And so what kinds of maintenance are these robots doing? Are they maintaining the different bits of equipment, I'm assuming?
Exactly. So at CERN, we have around 50 kilometers of accelerator facilities, tunnel, harsh environment, mainly also underground. And maintenance tasks ranges from simple activities like taking pictures or visual inspection to check the status of some facilities. We also do environmental measurements. So we measure, for example, temperatures in the tunnels, oxygen percentage. We measure also airflow. We measure magnetic field presence, also radiation. So we try to actually have an idea of what's going on in all these different facilities. Mm-hmm. Maintenance tasks can also range from tasks that humans do, for example, screwing, unscrewing, sewing, cutting cables. We also, most of the time, clean some environment from radioactive dust, for example, to make the environment more proper, more clean for human to intervene.
Okay. And so I'm assuming most people are familiar with CERN in concept, that, that it's a particle accelerator. I imagine fewer people are kind of aware of the details of what that really means. So you mentioned it's a harsh environment. You mentioned radiation. Can you talk a little bit about the extreme environment that we're talking about here?
Yeah, actually, extreme environment is mainly also due to accessibility. So our machines are, for most of the length, built many years ago. So they were not meant to be accessible by robots. We have some machine built in the 60s, for example. So robotics was not existing at the time.
Yeah.
So one of the first challenge we have in using robots is also accessibility. So how the robot can go in an area, because most of our areas are built around humans. So we know how, for example, to pass through a hole, or we can climb stairs. These are simple action, then for robots are very, very difficult. Then we do particle physics at CERN, and there is a risk of radiation along the accelerators. So we try to use remote system as robots as much as possible to keep ourselves and all our colleagues as much as possible away from from this kind of dangers. In some facilities, we also have a high magnetic field. And with high magnetic field, sometimes we can intervene also with robots without turning off this machine, for example. And this increase the availability of our machines. Of course, all the usual robots have the goal of increased maintainability, so the way how maintenance is done as best as possible, and improving the maintainability of an accelerator or in general of a plant. This, of course, increase the availability of the machine.
Yeah. And so you mentioned stairs. I can see that robot dog would be a big advantage there. Can you talk a little bit about some of the other ways that your new robot dog is helping out, what kind of jobs it's tackling?
So the quadrupeds, or what we name the robot dog, actually, it's for us is a tool we took from industry, we integrate in our control system. We're adapting a bit to be compatible also with the rest of the robotic pool. A part of doing stairs, he can also crumble across pipes and tubes that are on the ground, for example. This type of task, then an ROV hardly can do, or if can do, for example, a robot with the wheels or with the tracks to pass over a cable or a pipe that is on the ground, actually has to touch the pipe.
Yeah.
While with four legs, like a dog, you can avoid of touching things that are on the floor while you are passing on top of them. And this is an added value that this type of robot is bringing to our robots pool. And we are also using in combination with other robots to have, for example, different angle of views while doing teleoperation intervention, for example. Or we have bigger robots that have bigger batteries, so it means much higher availability in terms of time, and then they can deploy for long distance the quadruped, the new robot, in some facilities, and then the robot, like I say, wakes up from a bigger robot and then do the intervention, that does the intervention in the tunnel.
Yeah. Okay. That makes me think about the control. So are you teleoperating these robots, or is there some degree of autonomy in their behavior?
It depends on the task. It depends on the robot. Few robots are completely autonomous. These are the robots that mainly we have built in-house, and we master all the control and the hardware electronic part. Autonomy means most of the time for us autonomous navigation, so they can navigate in the tunnel and take autonomously measurements of the tunnel without an operator really driving. This is mostly when we do environmental measurements, like temperature, as I said, radiation, or oxygen percentage in the environment. For teleoperation tasks, we hardly have repetitive tasks. So this means all the time we need to do a task like screwing, grasping something. We are not in an industrial environment where all our connectors are, first of all, in a very good shape, because due to the age or radiation, they get damaged also.
Yeah.
So we need, in teleoperation, as we say, user-friendly interface and operators being in the loop to adapt, let's say, the action of the robot depending on the needs and on the specific intervention. So it really depends on the task. I mean, we can have some tasks that they need autonomy, and then we have autonomous robots, both in terms of controls and decision management, actually. But for many teleoperation activities, I would say 95% of the time we have the operator in the loop, and these are tasks that needs a human presence, actually. No, not presence in the tunnel, but it's a human action.
Yeah, that makes sense. And I might be wrong in this, but I was assuming that, if you're doing inspection or you're doing maintenance of the particle accelerator, that it would need to be turned off. And obviously that means it's not collecting any data. So that kind of puts you under some kind of time pressure to get it back up and running and doing science as soon as possible. But then obviously on the other side of that, precision is really important when you're talking about expensive, sensitive equipment. So kind of how do you manage this trade-off between like speed and precision in the robotics at CERN?
That's a very good question. Actually, I don't have one answer on that. I don't have for sure the right answer. The answer might be that we adapt to different situations, and the strategy that we take comes from experience. I mean, we are operating now these robots for more than 12 years. And as you said, we have always to leverage speed and quality of the intervention. And most of the time we improve the quality, just making more time or having more time to have an inspection, to take more picture, to study a problem. So this means more time to be in the tunnel and more downtime for the machine. That has also a cost.
Yeah.
Of course, all our colleagues, operators, they want that we go out from the tunnel as soon as possible. Same problem also human intervention have.
Yeah, that's true.
So, and the decision is taken, let's say, discussing with equipment owners, with equipment responsible, with operators, with safety responsibles. And we always have to have, let's say, a leverage between the time that we take and the quality. We know that, of course, higher is the quality of the intervention, and most probably less is the chance that the problem reoccurs. So this is really discussed in each case for each specific intervention. But I would say the answer of which type of tool, which type of robot we use comes most of the time from the experience we have in using these tools.
It sounds like a very fun and interesting but challenging job.
Yeah, there's a lot of fun, but as always, everybody, no challenge, no fun.
Yeah.
And of course, we have a lot of pressure when we intervene with robots. And what I really stress all my team is the fact that robotic is actually based on trust also between people and machine. If we don't trust this tool, we cannot use them. And also, if our colleague don't trust this tool and don't trust our job using this tool, of course, they won't call us because we might do some danger that can make things worse than the present situation. So it's a challenge, it's fun, but we know that we need to keep the risk really low.
Yeah.
Same thing for a human intervention, but of course, all the time a human intervene in a challenging task, the brain makes all these equations, and we're not aware about that. While when you have to use an external system and you have to trust an external system, then you need to decide most of the time to play on the safe side.
Has it been challenging to build up that trust in the robotic systems, with your colleagues, with the other people who work there?
I would say at the beginning, I was a bit scared because I felt when we have introduced these tools, not a bit of a barrier, but when people didn't know what this tool could do. This was the first. And I think the key there at the time was to start with simple tasks. So to show them not that we already could do complicated tasks like, pipe inspection or sewing, welding in situ. These are very complex tasks to be done by robots. We started with simple tasks like taking images in dangerous environment for human. And we were taking very high quality images with these robots. Already there, the people will say, wow, this is really an added value because we can understand from these high quality images. You took the time with the robot to have picture from different angles. So we understood what went wrong, how to improve things. And we start step by step. And we continue with more and more complicated tasks. And this helped us a lot because people got the time to understand that these tools can have an advantages. And also, we never said, and even today, we never say that robots can do everything. Of course, this is not true. But we need to understand that they might do, for example, sometimes 20% of the job. But already, in this case, they could remove 20% of dangers for human. This is already an added value. So we are also intervening in collaboration with human. We are preparing the intervention for human. We are cleaning what our colleague leaves after an intervention, for example. And I mean, it's not that the robot can do everything because maybe they can, but with the incredible amount of preparation time that sometimes we don't have, or development times that sometimes we don't have. So, and then another aspect that we pushed a lot is to understand people that a robot is not, it can be a humanoid, but we don't have to think a robot can do the task like we do with 2 arms, for example, 5 fingers. So the tools can be adapted to the situation, the robotic tools, and they can be completely different with respect to the way how we are built, let's say, and the way how we do things. They can do things much more different.
Yeah, that's a really good point. Thinking beyond CERN, to what extent do you think the systems and the processes that you've been developing can be applied to robotics in other harsh or extreme environments?
Well, this is a very good question. Actually, we build the controls and robotics not really focused for industrial application.
Okay.
I see a lot of common things with environment like mines, mine inspection, for example, or nuclear power plants to have maintenance in this type of facilities. Offshore, for example, all type of plants environment that might be dangerous for humans. We are starting this year to test our solution to do remote maintenance in synchrotron light sources. Synchrotron light sources are not particle accelerator like we have at CERN, but they have similar challenge that we have, and we are collaborating with some other institutes in Europe also to promote and to see how they can behave in similar but also different environment like synchrotron light sources.
Brilliant. Yeah, that's really interesting. Mario, it's been fascinating talking to you today. I've been chatting to Mario Di Castro, Mechatronics, Robotics and Operation Section Leader at CERN. Thanks, Mario.
Thank you very much. Take care.
Thanks for listening. If you enjoy Robot Talk, please do share the podcast, subscribe, and leave a review to let us know what you think. And make sure you check out our social media channels to see a photo of some of the robots used at CERN for remote maintenance. We're at Robot Talk Pod on all the socials. Next week, I'll be chatting to Isabel Ormrod from the University of Bristol, all about human-centred design and women in robotics. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.